Hello and welcome to this month's In the Labs with Tim Sway COVID-19 edition. I was supposed to go to the 3rd annual Maker Central in England this year and be a part of the Vectric team at that event, share a project with the people at the event, and then share the project with you online. I was really looking forward to this, and I had the project all done and filmed and ready to go. And then the world kind of got put on its ear. So everything's been pushed aside, and that left me with needing a project for this month. And I didn't want to use the one that I had saved for the event because I'm still trying to be optimistic that event will happen at its rescheduled date later this summer and I'll be able to use it then. So then I decided to come up with a totally new project. A lot of you may know that I make guitars basically for a living, and before that I used to play music for a living. You know, learning to play a musical instrument, especially guitar, is something that's on a lot of people's lists and they don't really have the time or the money or the resources to do it. So I came up with this idea. This is a guitar-like instrument that is cut from a single block of wood, and I used basically all stuff that I had laying around my shop to do it. It took me about 4 hours to make, and the only parts that you would need to buy are about $10, and they're readily available on most internet sites. This is a very versatile little instrument that plugs in, or you can just play it like it is and still hear it enough to kind of get the idea. And it works in the same basic way as like a guitar or a ukulele. You could string it like a ukulele, you could string it like a guitar. Right now I have it strung like the 4 bottom strings of a guitar. You could make it have 3 strings, you could even fit 6 strings on this. It's all very versatile, and I can't wait to show you and tell you more about it, so why don't we just jump right in. First thing I did is I went to this website called ekips.org, that's spike backwards, and they have this great fret calculator on there where you can kind of type in all the numbers for the scale and the length and the width that you want, and it'll create a DXF file for you. Now the DXF files are a little annoying because the lines across the frets are actually not one solid line, they're just 4 lines together, so when you're cutting them it's like separate toolpaths, which usually I go in and fix, but on this one I didn't bother. And you can see what I'm doing here is I'm taking that basic neck measurements that I had created and I'm sketching out a guitar around it. I pulled some shapes and some measurements off some other instruments that I already have files for and copied and pasted them into this, and then edited it down to make it like a little half guitar that would sort of be very small to carry but still had that sort of shape to put over your leg. In the later version of this that you'll be able to download, I actually changed the shape of that cutaway that goes underneath the fretboard to make it so your hand can fit in there a little bit better. And you can see everything's about being small. This circle is for the piezo pickup, and I want it to be right under the bridge that's represented by that line there. And then I put some cavities in the back for the electronics, and we'll talk a little bit more about that later. Now I had to model out the back of it. I wanted to make a radius for the neck, and so I created 2 simple arches, and I did a 2-rail sweep along that to just create this very basic neck shape. And then I also turned the body and the headstock into 3D models just to build them up, but they're really just flat surfaces. There's a little bit of trickery that needs to be done in the tool paths because of these different layers and stuff, and we'll talk more about that later too. Here you can see as I'm creating the tool paths, I want to reduce the headstock down a little bit, and I also want to reduce the body down a little bit, and that will simulate having a fingerboard up higher. I used a very small 30-degree V-bit just to etch into the fingerboard where the frets would be, and we'll talk more about that later too. And then a 1/4-inch end mill and ball nose to do pretty much everything else. Since the body and the head are recessed, some of these holes that I created, you end up cutting a little bit of air before the end mill actually contacts wood because the wood is lower than the file's initial claim. And so you had to adjust for that math in the process. For example, the hole that the piezo will sit in is 0.08 inches deep, but the tool path is 0.28 inches deep to compensate for the 0.2 of an inch of wood that I had already removed. Now I can go in and edit my passes, so the first pass is a little bit deeper and then I can make the rest of them appropriate so I do fewer passes and save some time, but I like to just sort of run things straight and clear like this to help keep my head straight and keep the math straight, and then once I get a little more comfortable with the file I'll go in and make those types of edits. Okay, now that you've seen how I created the file, I'll let you know that the file that you're going to download is actually a little bit different. I made some mistakes that I discovered as I made this prototype that we'll talk about throughout the build, and I've changed them all and made it even better in the actual file. But before we start cutting, let's talk about some of the materials that you will need to do this. Most of the stuff I used to make this are probably floating around your shop already, but there are a few instrument-specific things you'll need to buy. One is some kind of tuning key, and you can find these on pretty much any online retailer. I find on eBay a lot. I can get them very inexpensively and in odd numbers. And one of the things I changed on the file was I made these holes accept a more traditional size and shape tuner that would stick off the side, and made them in better locations for that. The other thing that is something you might not have laying around the shop is this piezoelectric transducer, or a piezo pickup. We just call them piezos usually. And this is a vibration sensitive pickup, so it feels the pressures and the contact of all the things moving around, and it translates them into sound just through a standard 1/4-inch jack. So these are also readily available on most online retailers. Again, I usually find them on eBay for like about $1 a piece, and where you might end up spending more like $8 to get 4 inexpensive tuners. For the nut, I used a piece of a 5/16 inch bolt, and the nut is this piece that's right here. Another thing I changed in the file is that to get the string length perfectly correct, I had to remove a little bit of material here to move this nut a little bit closer, because you can see that the string actually bridges it back at the center of the nut, so it's a little bit too far back. Nerdy nut, blah blah blah. So that's been fixed, don't worry about it. And then for what they call the bridge on the instrument, I used a 1/4-20 bolt with the nut on the end to simply hold it in place. These are, again, things you probably have laying around the shop. I just stuck 2 screws into it to hold a strap. You can do whatever you want for that. And then the only other thing is I used a little piece of hollow core door, and there is a vector for the shape in the file. I cut this out of my laser, but you could do it on your CNC or by hand or whatever, just to cover up the hole where all the electronics are. And you can see I used just some little nuts that I had laying around for holding these strings in place. One of the things I changed on the file was I drilled the same width hole all the way through the body, so in theory these nuts could kind of wiggle their way down further, and I fixed that on the file. So you'll see there is the big hole in the bottom, and then I put a optional hole with an 1/8 inch end mill to drill out all the way through from both sides for the strings. I listed those files as optional because you might just choose to go over to your drill press and just, because it might be faster and easier than changing out bits on your machine and whatnot. And then the strings I use some used guitar strings I had laying around from a recent guitar job. You might need to buy some of those. You can use steel strings, you can use nylon strings, you can make this a 6-string instrument by adding a couple holes up on the headstock. You could use nylon strings to put less tension on it if you feel like the wood that you have isn't strong enough to handle the pull of the steel strings. Sky's the limit. You could put 3 strings, 4 strings, whatever. Now the other thing I want to talk about is the frets. On this one, I did a really simple thing, which you'll see later in the video, but you have a lot of options. So basically the right way to do it is you buy what's called fret wire, and you can see fret wire has like a round part on the top, and then there's these little teeth. Now when I make guitars for real, instead of using a V-bit that I'm going to use to just etch the position lines here, I have a little teeny tiny end mill that's just the width of this that I cut all the way in, and I actually bang the frets in. If you want to do that, you can. With the line that's in the file, you could actually just leave it as a fretless instrument and just leave those lines there as a visual marker, maybe fill them in with epoxy. Another option you can do to make frets is use just these little finish nails and glue those right on there. In the past, I've used cotter pins because they're stainless steel and they're flat on one side. And so if I just cut and they also come in different sizes and scales and whatnot, so you can cut that round head off. And here's you see one, this is an old one, that you can see is flat on one side and half round on the other, almost identical to a fret. You can glue those right down as well. But for this instrument, what I use is 16 gauge brad nails, because I have a whole bunch of them in the right width, and they're just perfect little squares that I was able to glue right down and shape out pretty easily. So don't get hung up on that. The idea of this is you don't need to spend a bunch of money. You're talking about $10, $12 in parts and some scrap wood, scrap bolts and nuts, and have fun with it. If you want to use steel strings, you're going to need a pretty hefty piece of wood like oak or something maple. I use this reclaimed Kumru decking because I'm almost out now, but I have a lot of it. If you use a softer wood, you could just use nylon strings. You need a block of wood that's at least 30 inches long by at least 5.5 inches wide by at least 1 inch thick to create this file. And so you'll also need a CNC machine that can handle that 30-inch board. But if your CNC is only 2 feet square, I bet you could get creative and fit this in diagonally. Now here you can see I'm using a 30-degree V-bit that I'm just lightly etching the fret lines in. Again, I would use a special end mill that I have and actually cut them a little bit deeper if I were doing it with proper fret wire, but for this, I just wanted to make reference to where they are as accurately as possible, and there's nothing more accurate than my CNC machine. Now I'm starting to reduce the height of the headstock and the body just about 2/10 of an inch, and I'm just using a 1/4 inch end mill for that. And there you saw I was cutting a little bit of air before I started drilling out my holes, which could be corrected in the toolpaths. I just haven't done that yet. If you ever want to know what I'm up to, I do a lot of Instagram stories in real time and show what my future projects will be there. I left my dust boot off just for filming so you could watch this. You're welcome. The file has 3/10 of an inch indexing holes that go into the top piece of my work as well as the wasteboard of my CNC, and that is the diameter of a pencil. So I use just like broken and short pencils a lot of times and cut little dowels from them. I like to use that because that's something everybody has on hand, so I know that you can do it too. Okay, so maybe I'm not Mr. Efficiency with my cutting air while I'm drilling holes and with my lines that I didn't fix, but this is something that I think is important to discuss, and I went and intentionally did it wrong first so I could show you. I want to talk a little bit about the weirdness of what was just going on. You saw that I did a roughing toolpath using a 1/4 inch end mill around the entire perimeter of the instrument. Now what I did is I had set an offset around the final shape of the guitar so it went a 1/4 inch over on either side. Now what that means is that this body, because it's technically a 3D piece, it feels like it has to go down and clear away all of this material around the edge of this body, even though that's just going to be a straight line in the end of the day. Now on the neck, on the other hand, this is a radius that curves all the way down to the wasteboard, so it does need to go around there. So I set it like kind of a traditional way of just doing this offset to show why I don't normally do it that way. You can see that it only goes back and forth in straight lines, and so it gets kind of jammed up here and it has to go back and forth and up and down, and it's kind of a waste of time and it's inefficient. The other thing it does is now it makes it so my entire model is cut out almost all the way to the wasteboard, so that's why I had to add those giant tabs to it in the file. What I normally would do to correct this is I would run separate roughing and separate finishing toolpaths for this instrument. I would run a toolpath that is just the exact perimeter of the body with no offset on this part, and then the neck I would create a box that's oversized and run a toolpath in there so it can go all the way down to the wasteboard and clean that out. Headstock I would do like the body because again that has a straight edge, and now what that does is it alleviates the need for me to add the 3-dimensional tabs that I put in, and it also gives me a faster toolpath, and now all of this is secured. I can just add regular tabs, cut it all out. My neck gets what it needs all the way to the bottom. So it's a little bit more complicated on the coding end, but on the machine end becomes much more efficient. And the file that I'm going to send to you is going to be set up that way. Here you can see what I'm talking about. I reduced the back of the body by just 5/100ths of an inch just to kind of clean it up and get it to the finished height that I want, but there's no need for all of that back and forth and going around the edge, because when I do my final profile toolpath, it's going to take care of all that anyways. But then in the neck area, I do want to go all the way to the wasteboard just to save myself some work cleaning it up in the end. Now for these holes, I don't have to cut air because I can click the tab that says Project Toolpath onto 3D Model, and then this time I need to make sure that I make the hole exactly how deep I want and not compensate for any material that might have been removed. When I had the V-bit in, I carved my logo into the body here, and I just filled it in with some black Starbond CA glue to make it show, but you could just delete that if you don't want to carve that into your project. Hindsight being 2020, I should not have scraped the excess off. I should have hardened it first and then sanded it off, because some of that black got stuck in the grain of the wood. You'll also need to drill a small hole to connect the piezo pickup into the wiring cavity in the back, which is pretty easy on this guitar. I set it up so it's pretty much just a straight line. I didn't really think about how a little bit of that wire would be under the piezo, and so when I glued it down, it was not perfectly flat because of the wire. And then I glued these discs in that I cut out of my laser out of some veneer, but you could also cut them on the CNC. The profile is right there in the file. And they were going in a little bit crooked because the piezo was crooked. I sanded them in, you could see the seam. So I added to the file just a little slot in there for that wire to sit in, so that won't happen to you. But see that seam there where the two pieces sort of overlap? And now here was my bright idea for the fretting. I took these 16 gauge 2-inch long nails from my brad nailer, and I simply super glued them onto the fingerboard, just right on top of that line, the best that I could. This worked okay. It was a little treacherous to get them lined up right, and you'll see I was liberal with the super glue, and I wasn't too concerned. You'll see why later, although maybe in the future it would have been better to cut that slot a little bit wider, maybe measure the nail and cut the slot so I'd have something to put the glue into and not have that as much excess glue sort of seeping out. It was basically just gluing them onto a flat surface, but they held well, and I just nipped them off and cleaned them up. This is like a DIY version of a guitar tool that's out there. I just glued a file to a block of wood, and I use that a lot on leveling out my frets. So you want to make these nice and smooth on the edge because your hand is going to go right over them, and you can see that I'm giving them a bit of a bevel, which helps make them feel better. It's a little bit of a pain in the neck to do this stuff, especially with brad nails, but it didn't take me as long as I thought, and it turned out better than I expected. After cleaning up all of the ends and making sure there were no sharp spots, I then used my fret file and filed over the entire fingerboard to make it as flat as I can, because if just one of them's a little higher than the rest, then it will buzz and be a real problem. You can kind of look down it and, like I was showing the camera, and see if anything's high. And then you want to find something else that's flat, and you can just glue some sandpaper to it if you don't want to do that fret thing. And do the same thing. You just want to make sure you're transferring a flat surface to that fingerboard and you're not pushing down anywhere to create any divots. It takes a little bit of practice, but I think you'll do okay. I used a razor blade to clean up a little bit of that excess super glue, but here's why I wasn't concerned about it. I went to the thin Starbond glue and just brushed it onto each fret to make like a super glue finish over the fingerboard. It kind of helps to sort of tighten up the grain a little bit, make it a little bit stronger, and also cover some of that excessive super glue that might have come over the edges. Again, this is not a pretty job and not how I would do it professionally, but it worked. I just used linseed oil for a finish, and then I taped up the fingerboard and cleaned up the frets a little bit more. I sanded from about 400 grit to about 2,000 grit with just these little plastic bags I have kind of rolled up in a ball to help me kind of squish over them and get the edges and sides. I didn't get too carried away. I mean, they are nails after all. If you really want good frets, then spend a couple bucks on the fret wire. This is your typical 1/4-inch guitar jack. You'll see that there's this black line here. That's an insulator. The positive line is at the tip, and the negative is the sleeve. And when you plug it into this jack, you can see how the tip touches just that tab there, insulated, and then the negative is the entire sleeve of the jack. So what we do when we're soldering it is we want to run the positive line to this tab so we can just look at it and follow and see it between the insulation, and it goes over to this tab right here. And obviously if you have two wires, the red is the positive and the black is the negative. While I had the soldering iron out, I used it to just make little visual markers on the top of the fingerboard where the 3, 5, 7, 9, 12, and 15th fret are, but I didn't do it on camera because I wasn't paying attention. The bolts I picked out were remarkably close to the perfect height. I was pretty impressed with how well I got the math, but if you do need to adjust the height, you could use a little triangular file and just actually dig into the metal and lower the strings into the nuts and bolts to get them to the height you want them. Here's something you'll need to know, and like I said, I addressed the file already to compensate for this nut that I created. The string length is very important. For the frets to work right and for the thing to play in tune, you have to have your bridge and your nut exactly the distance that lines up with your frets. So I made this nice and simple. I made this a 20-inch scale. It's a little bit longer than a ukulele and it's a little bit shorter than a guitar. That means that from here to here is exactly 20 inches. And you can just measure that with tape measure. The other thing you can measure is to the 12th fret, the one that has the double dots on it. That's the exact halfway point, so that should be exactly 10 inches. And then there's, you know, all the other math in between. So you can see if I put my tape measure there, I get exactly 10 inches at that fret. And then all the way to my bridge right now, I'm actually closer to 20 and a half because I have the wrong nut on it. And I was able to just move this to the right position to where I go. But that's one of the cool things about using nuts and bolts in your instrument is that this isn't fixed, so you can move it and you can tune it and kind of compensate for errors to what's going to work best for you. And the other thing I like about it is you can adjust your string spacing. If you like to want to have all your strings really close together, you just slide them over to that groove. You can make them all really close together, and that way you could actually fit, like I said, you could fit multiple strings on this instrument. The next one I'm going to make with 6 strings because I think I can fit them and it'll be cool. 2 other improvements I made to this file. One is I added position markers on the fingerboard, so there's just little circles that you can mark in to help you visually see where notes are. The other is I cut the larger hole on top, recessed in just about 1/8 of an inch like I did on the bottom, so you could duplicate these nuts up here because you can see what might start to happen. See how that string, focus, see how the string is cutting into the wood. Eventually that'll stop and it'll get to a place where it's happy, but if you put those nuts in the top as well, they'll keep the string from cutting into it. So again, this here will have the wider hole at the top and the bottom for the nut, and then a skinny hole going through for the string so the nuts have wood to crush up against and sit still. Remember sports? Do you want to make one of these? I hope so, and it's easy to do. All you have to do is go to Vectric.com and log into your V&Co account to download the files that I created for you today. And again, my file is even better than this, the one that you're going to be able to download, so check that out. Because of the 3D carving on the back, it is an Aspire-only file, but it is worth it, and I hope you like it. The other thing I want you to do is please share pictures of the instrument that you make using my file as a template. I would love to see what you come up with, especially if you add or remove strings or do some creative stuff with this basic file. Share it with Vectric, share it with me. I'm just Tim Sway. You can find me all over the internet under that name. However you want to do that, I would really appreciate it. And happy making. Please be good, be safe, and I will see you next time.